Okay, polynomials are these awesome little things. They're fantastic. You're going to see polynomials all the way up through calculus. And maybe even beyond. All right, so before we can get into it, we have to know what they are. What is a polynomial? Well, first of all, before I can talk about polynomials, I'm going to talk about monomials. And let's look at these prefixes. What is that, poly? Polydactyl, you ever hear that? Polygon, many. And this means nomial many numbers. They're talking about that. What does that mean? Monorail? One. Yes, ma'am.
Number, variable, or number, it basically means any sort of number that you get.
Okay, all right. So any number, absolutely. 10, that's a monomial. Any variable, what would that be? Give me an example of variable. X, Y. That's a monomial. Or a product of a number and one or more variables. So 2x, 3xy. How about 1/2 z squared? Is that a monomial? How come, Ryan? Because it's just a number. And this is z times z, right? Multiplying variables. That would be a monomial. And here's important, whole number exponents. So if I had 3 times x to the minus 1, is that a monomial?
No.
What does it mean to be a whole number? Can't be a decimal. Can it be negative? No. Whole numbers are 0, 1, 2, and up. If you add negative numbers, those are integers. So whole numbers do not have negatives. How would I write this without that being negative? Yeah? Right. This is not a monomial. International interdict, not. So if you see anything with a 3 over x, not a monomial. No, it's just not a monomial. What? Say, what is it? What about what? You get it? Okay, so that's what a monomial is. Degree. A degree of a monomial is how many variables are being multiplied. This is the definition, some of the exponents of the variables, which is how many. So if you have 3x, what's the degree? 1, because there's one variable. What about 3x squared? What's the degree? 2. What if you have 3xy? What's the degree? Multiplying 2 variables? 2. What about you have 3x squared y to the 3rd power? What's the degree? 5. Exactly. Okay? Example. So we're going to figure out if these are monomials or not monomials. Now this is not on your paper, so we're just looking up here now. Okay. Does this fit the definition? No. Is it a number, a variable, or a product of number and one or more variables? Yes. What is its degree? Hang on for a second. If degree is the number of variables, how many variables? 1. It doesn't have any variable. This is not a variable, it's a constant. So what's the degree? 0. Right? A constant. I hope you're all listening. Look at the board. Okay, so there is no variable. Its degree is 0. Is this a monomial? Yes. Yes, it's a variable. What's its degree? 1 variable. Is this a monomial? Yes. Yes. You could rewrite this to look like this. 2/3 x squared. Right? Number times. So what's the degree?
2.
What about this guy?
No.
No, why not?
Because
So you can't have a variable in denominator because what's another way I could be writing this? I could write it as 7 times x to the minus 2, right? Aren't these the same? Happy here, unhappy up here, that's negative. This is not a whole number exponent, so no. What about this?
yeah.
No.
Wait, what?
Why not? This is not a whole number, it's a variable. You can't have a variable exponent and be a monomial. Now, listen, you can do this in math. It's just not a monomial. What about this thing?
Yeah.
Yes. Think of this as 8 over 11 times this big thing. What's the degree?
9.
You got one variable, 3 more variables, that's 4. 5 and 4 more. Degree is 9. Makes sense? Sort of?
Yeah.
Okay. Monomial. So we have to know what that is first. We know what a degree of a monomial is, and we've kind of gone through some examples. Let's look at polynomials now, okay? You told me that means many. You got many of them. Now, I've had some problems with this definition for some people. Now, it is a monomial. So anytime you have a monomial, you can call it a polynomial. Or you add them. Some of them. I've had some people say this is just wrong. Poly means many and a monomial is just one. And I'm sorry, I agree with you. But the definition says you can say a monomial is a sum of monomials. So give me some monomials. You could have an x
9.
plus a y, right? Is this a polynomial?
Yes.
Yes. Plus maybe a z squared?
4.
Sure. Right? This is a monomial. Now what if I add 1 over x?
No.
Not a polynomial anymore because one of them, one of the terms, right? These are all terms, is not a monomial. Yes, sir.
X plus y plus.
Okay. He wants to know if this is a polynomial. Is this a monomial?
Yeah.
Is this a monomial? Is that a monomial? You got a polynomial. Okay? If all the pieces are monomials, it is a polynomial. Well, what about if it's this? What about 3x minus y? But since you're adding, yes. Because what is this really? This is like adding a negative. It's like adding something with a coefficient negative. So that's a yes. Okay, now to find the degree of a polynomial, it's the greatest degree. So what do I mean by that? Let's look at this one. You wrote a lovely little, it is, it's a very nice polynomial. What's the degree of this monomial right here? 1. How many variables are there? Okay, how many variables here in this one? How many variables here? Each one has a degree of 1. Now listen carefully. The degree of the polynomial is not adding these. It is what's the biggest number you got? 1. Degree 1. Let's look at this one. Okay. What's the degree of this monomial? What's the degree of that one? What's the degree of this one? 2. What's the degree of the polynomial? 2. It's just the biggest one. Okay. All right. So let's look at this one. This one I think is no, it's not on your paper either. Okay, we're just going to look at this one now up here. Is this a polynomial or isn't it? And if it is, what's its degree? So is this a polynomial?
Yes.
Yes. It's a monomial, so it's a polynomial. What's its degree?
0.
0. Because there's no variables. Is this a polynomial?
Yes.
What's its degree?
1.
1. Good. What about this thing here? No, yeah, you know. Why not, Ben? There's an x in the denominator. No. You can't have variable in the denominator. You're not good at it? Is it kind of clearer? No. No? What's the matter? Guess the question.
I don't know.
Just don't even know yet. All right, I'm going to talk to you, Sam. No. Is this a polynomial? Just look at each one.
Yes.
I'm talking to Sam.
Yeah, come on, guys. You're ruining my life.
You're ruining his learning experience. Is this a monomial? Is this a monomial? Is this one? Is this one?
Yes.
So is it a polynomial?
Yes.
Yes. Now I'm going to work on degree, my friend.
Well, I know the degree.
What's the degree?
Oh, well.
Well, I don't know. All right, what's the degree of this one? We're just going to do one at a time. 4. What's the degree of this? 4.
Gosh.
What's the degree of this? What's the degree of this? So what's the degree of the polynomial?
4.
You do know it. Why are you saying you didn't? He knows it. I don't. I just didn't know I know it. Okay. Questions? No. You just how many variables do I have? I've got 2 x's and 2 y's. 4. I've got 1 x and 3 y's. There's 4 variables. There's 1 variable. There's 1 variable. Take the biggest, and that's your polynomial degree. Okay. Alrighty, let's talk a little bit more about what a polynomial looks like. We write them in descending degree order. What does descending mean?
Isolated.
Biggest to smallest, right? Okay, so like this one back here, it's a correct polynomial, but if I wanted to follow what our convention is, I'm gonna put the biggest one first. If there's a tie, I guess alphabetical order. That's probably a good bet. So here is one, see descending degree. This one has degree 3, degree 2, degree 1, degree 0. Okay? You know what a coefficient is? This one you should have before you walk in this room. What's a coefficient? The number in front. It's like what am I multiplying these variables by, this variable by 2. What's the coefficient in this term right here? 1. It's what am I multiplying by? A number. What about this term right here? Negative 5. And then what about this thing? It's a constant. It is 12 is I guess the coefficient, but I don't really have the variable there. Do you want to think about this as being x to the 0? Because what's anything to the 0 power? 1. So you can think of 12 as a coefficient if you want, but we call it a constant. Okay? So let's see. Let's put this one. This one is on your paper on the middle page one. Everybody's listening and doing this. So let's rewrite this. So which term goes first? Who's got the biggest degree? Yes, Matthew? Negative, you corrected yourself. That negative is attached to this variable. Then what? What's the next biggest one? 15x plus 15x, and then plus our 3. So put it in this standard form, which is descending degree order. Excellent. All right, now let's figure this out. What's the degree of this polynomial? 3. Because this one has 3, this one has 1, this one has 0. 3 wins. It's biggest. What's the leading coefficient? Negative 1. Awesome. We're going pretty fast here. Are there questions? Because the ones who get it are chatting it out. If you're not getting it, let me hear a question. Yes?
Wait, how is negative next?
How's what?
How is negative next to the thing?
It's degree. Remember what degree is. Degree is how many variables I've got an x times an x times an x. So that's got degree 3. How many variables here? 1. How many variables here? So this one wins. Degree 3.
Why is it negative 1?
Because the leading coefficient, as you get it in this standard form order, is the coefficient in front of the monomial with the biggest degree. So that's here. And it's negative 1. Other questions? These are great questions.
I get it.
Ask them if you have it. This is not hard, but if you don't see it right away, yeah?
So if it's not in the standard order, it's not a polynomial.
Oh, it can be a polynomial, it's just not in the standard form, right? So if I put, this is a polynomial, and it still has degree 3, but by convention, we put them in descending order. It's very easy to see the degree if you do that. Yes?
But so standard form it has to be in different order.
Descending degree order. Yes? Yes, sir?
How did you standard form for like 5
Same thing, degree order, right? Descending degree order. And what do you mean by 5 or 6 numbers? Give me an example.
like negative 15x minus x squared plus y cubed minus 5.
Okay. Let's put that in descending degree order. Which one has the biggest degree? I'm going to put him first. Then he's the next one, right? Then him. Then that. What's the degree of this polynomial, Ryan? 3.
Oh.
Okay? Makes sense? We do that so we can see that. And it actually is helpful having it like this. Yes, sir?
What if two numbers are the same?
What if 2 numbers have the same degree? That's a great question. So let's say, and I put another z squared here. So I would probably do it as y cubed minus x squared plus z squared. It's a tie, so I'll just put them there. Minus 15x minus 5. Usually alphabetical order there. But yeah, that's what I would do if that's the case. And you do your best. When there's a tie, you do your best. Yes?
What if there's like 6 numbers with the same degree?
Then you just do your best, but make sure they're in the correct order. If they're all squares and there's something that isn't, right, it goes before there. If they're a tie, group together. Yes?
So the leading coefficient is the coefficient that's in front of the greatest degree.
Yes. What's the degree of this? I'm sorry, I'm not degree. What is the leading coefficient? 1. It's helpful to have it in degree order. I can see it. Leading coefficient is 1. Okay, awesome questions. Those are really fantastic questions. Let's see. If you have a polynomial and it's got 2 terms in it, the term again is like this is a term and this is a term. We call them a binomial because that means two, right? Like bicycle, right? Two wheels. So binomials have two terms. What do you think you'd call one with three terms? We do, okay? Yes. And then we stop doing it, okay? So binomials and trinomials. This is a trinomial. This is a trinomial. Okay, it's not on there. If you want to make that note, you can. But I think we can remember that. Binomial, trinomial. It's on there?
Yeah. Oh, yeah, the very bottom.
Okay. Okay. It is there. Alrighty. So this is the table on page 1. Let's see if we can figure this out. I've got a bunch of expressions. Two things we're going to do. Is it a polynomial? Yes, no. And if it is, how many terms? If it's not, why not? So 9, is that a polynomial?
Yes.
Okay, what's the degree? 0, right? There are no variables being multiplied here. How many terms? 1 term. Okay, let's look at this expression here. Okay, so is this a polynomial? Yes. What's the degree? 2. How many terms?
3.
1, 2, 3. Okay. How about this guy? Is this a polynomial? It is not. Why not? Why not? Variable, right? This one has, okay. So here's one reason why we have a variable up here as an exponent. There is another reason. Yeah? Because we can't have a radical. Now, you don't know this yet. Do you know there's another way to write the square root of n? You can write the square root of n as n to the half power. You're going to learn all about that now to the 2. Is this a whole number?
No.
No. So that's why you can't do square roots or cube roots. They give you a polynomial. You can have this as an expression. It's just not a polynomial. Okay? This guy, polynomial?
Yes.
No. Why not? Yeah, why not? This has to be a whole number, which means positive. So no. Remember what that is? That's 1 over n squared minus 3. Can't have them in the denominator. Nope. What about this guy? Yes, it is. Oh, degree.
5.
No.
No, it's
8,
8.
right? This one, how many variables? I've got 5 b's and 3 c's, so that's 8, right? And this one has how many? 5, 8 ones. And how many terms? 2. Okay, so does that make sense? Who's got a question on this part? There's all kinds of terminology. You're going to see it over and over. I'm going to use these words. If you forget and I'm saying, well, this one has degree 4, and you don't know what I'm talking about, I'm depending on you to raise your hand and say, I don't remember what that means. Because I want you to have that, okay? All righty. No. We haven't even gotten to it yet.
Never seen that.
What? We haven't even gotten to it yet. No. So we're going to learn how to do add and subtract and multiply polynomials. Yay. No, it's easy. This is the easy part. Right, Sam? Yeah, this is the easy part. You add polynomials by combining like terms. Who knows how to combine like terms? Raise your hand. Then who doesn't? What? The Bryans. You don't know how to combine like terms? If you know how to combine like terms, then you know how to add and subtract them. So let's take a look here. Whoops. All right, so these examples are on the bottom of page 1. It looks so complicated. Now look, a minus, a plus, a plus, a plus, a minus. Do I even need these parentheses? No, not really. So here's what you do. You say, okay, I'm going to start with the biggest degree. 2x cubed. Do I have any other x cubes? Right? How do you be a like term? The variable stuff is the same. Who else is an x cubed? No, 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 yes. Now look when I'm circling, what else am I circling? It's sign, not an x cubed. If you have 2x cubes and you add another x cubed to it, how many x cubes do you have? Total 3x cubed. Think about what you're doing. Think of an x cubed as like a creature. This is an x cubed and it looks like, here it is, it's got antennas. That's an x cubed. And then this is also an x cubed and he's got his antennas. So how many of these guys do I have? I have 2 of them here. I got 1 of them here. How many of those? 3 of those weird little things. So think of an x cubed as just a weird little thing. And I have 3 of them. Now, what? Because when you multiply, that's different. I am adding.
I get it now, I get it.
Yeah. What's the difference between adding and what would multiplying do? I'm not. I am adding. You have 2x cubed creatures plus another x cubed creatures. That's 3x cubed creatures. All right, let's look at my, oh, I see square. Now I'm going to make this just a different one because I'm looking at a square now. Look, I'm keeping the minus. So I've got 5x squared creatures. Do I have any more x squared creatures? Oh, here's one. So negative 5x squared plus 2x squared. How many x squared creatures? Negative 3x squared creatures. All right, I see an x. I'll use that shape, I guess. Any more? Only one x creature. Okay, keep it. And then a number. Minus 1. That's combining like terms. Let's try this one again. It's a plus. It's like I don't need those parentheses. So here's my x squared creature. I guess I was using glasses for that. Any more of those? There it is. 3x squared creatures plus another x squared creature.
4x squared.
And then I've got this guy. This guy. That's an x plus 4x. How many x's?
5x.
Well, I'll use low ones. Why not? So minus 6 plus 10. What's that?
4.
See? You guys know how to add monomials. It's easy. Just said. Right, Sam?
It's gonna be easier.
Yeah. All right, now minus. Thank you. Thank you for shushing everybody. Minus is the same thing, except first thing, you're going to distribute a negative. What do I mean by distribute a negative?
Multiply.
And what's that going to do? I can't hear everybody's talking. So tell me, what does that do?
It changes the signs.
All the signs will flip. So watch what happens. You're going to rewrite it, so this part's still okay. Now I've got a minus minus. That's a plus. I've got a minus and a plus. That's a minus, right? And then I've got a minus and a minus. See, all the signs flip. Now I'm back to what I was doing here. Let's see, 4x squared. So every more x squared creatures. Here they are. 4x squared plus 2x squared. Can we put them around parentheses? You don't have to. And then let me see. I like doing it in degree order. There is an x here, so I'm going to do that one next. Because if I do it in degree order, it will be in a nice standard form. Here are my constants. So plus 5 plus that's a 9, right? I just subtracted.
Yeah.
I did some more. Okay. Let's see. This is a minus, and I have to distribute that. So let's see. This part's the same, right? That's my first thing. First polynomial. So this becomes a minus 3x squared plus an x plus an 8, right? How do I get all this? I flip my signs because I'm distributing a negative. All right, looking for my x squared creatures. Here it is. 4x squared minus 3x squared. Yes, one of them. Brenna? I've got to do that first, right? Yeah, so it's here, right? And then I'm going to do x's. Okay, minus 3x plus an x. Minus 3x plus an x. What's that? 2x. Minus 2x. And I got some of my constant. Plus 13. So is this hard?
No.
No. Look at that. Oh, there's no that guy there, right? He says it's hard. Oh, Sam, is this hard? No. No. He has bad memories, believe me. He's just got some bad memories. Yeah, that's common. It's going to be fine. Watch. Okay. Multiplying. Multiplying is using distributive property, which you know how to do, right? So if you have something like this, how does the distributive property work? Yeah? Yes. Great. You know it. So we're going to distribute. Look at that thing. Oh, that's frightening. No. All right, so it's not. It's at the top of your paper. You can put the answer in, so you can watch up here and see how we did it. Remember how distribution works? This thing, there's that thing, there's that thing. What is 2x cubed times x cubed? I'm not adding anymore. Yes, sir.
2x is 6.
Yes. Remember, when you multiply with the same base, you add exponents. Excellent. Yes, ma'am. Okay, so it's 2x cubed times 3x squared. Excellent. Question where this came from. Right, 2 times 3, x cubed times x squared. You have 3x squared times 2x squared. That means I've got 5 of these x's here. Now be careful with this one. 2x cubed minus 2x. There's a minus here. Claire? Yeah.
Negative 4x.
That's it. X cubed times x. Right? Because you got 3 factors of x times another factor of x. You got 4 of them? And how about 2x cubed times 5? Brenna? Perfect. Okay. That is multiplying. That is multiplying. That's it. Yes?
What if the 2x cubed is like a whole nother equation?
Equation. What do you mean?
Like,
You want this equals that? You want that? Well, we're not ready for that yet, but we will. Yes. What do you mean? You should always be able to distribute, because remember, polynomials have a rule, which is there's nice, there's numbers, and these are going to be nice coefficients like this. There's going to be nothing in a denominator. Otherwise, it's not a polynomial. So I think, I'm not sure what you're asking, but I think the answer is yes. Now, if for some reason it looked like this, let's say no, it was written like this. You mean, what if it's like this? You can do that. Now, if you're unhappy with this, just rewrite it, right? You can use the commutative property of multiplication to rewrite it to look like something that's more familiar. Okay, great question. Okay, so that's how you distribute, which is why we learned the laws of exponents. Yeah, remember that? Okay, multiple distribution. This is the thing. Sam was like, I don't want to see this ever again. No, all you do with this, okay? And again, I put the answer on your paper so you can just kind of watch. Multiple. You're going to pretend the minus 4 isn't there. You're going to cover it up. And so I think that's what's here. So you cover up this part. Please stop talking. You're not going to know how to do it. So there's no minus 4. So it's like you're doing x times 3x plus 2. It's like you're doing that. So what happens? You get x times 3x. What's x times 3x? Yes, sir? For now. Just let me show you the steps. So what's x times 3x? 3x times 3x. You've got x times an x, which is an x squared. X times 2. 2x. Okay, now the minus 4 is still here. You're absolutely right. So now what I'm going to do, okay, we did this. I'm going to pretend the x is in here. And now I'm going to distribute the minus 4. So what's minus 4 times 3x?
12x.
And then what's minus 4 times 2? Now this is like, an add problem. Do I have any like terms? Yeah, look, there's our friend the x's. So that's going to be 3x squared. What do you have? 2 x's minus 12 x's. How many x's? Minus 8. You're done. What happened to what? I'm done. I distributed and I turned it into this. Yes, sir. I'm waiting. What was over here? Yeah, this is just telling you how to do it. The product is 3x squared minus 10x minus 8. And I think that one's on your paper, sort of? Yeah. Well, we didn't put the answer in, so you're going to put the product in. Do you see where we're on page 2? Kind of middle of the page? This was Sam's bad dream, foil, coming up. I hated foil. All right, now if you hate foil, Sam, you don't ever have to use it again. You feel better? Okay. Some people like foil. I'll tell you why. What is this thing? This is an acronym. What's an acronym? What's an acronym? What is that?
a word that each letter stands for one word.
Yeah, what's another example of an acronym that you know? Yeah.
DEI. Do Richmond's people incorporated from Phoenix.
Okay, then do okay. What else? Anybody have another acronym?
That's not equal.
Oh,
Yeah?
for basketball, use beef.
And what does beef mean?
Balance, eyes, and elbow.
Balance,
Awesome.
elbow, arm.
Yeah.
Okay.
Get it right.
That's just like this, except it's better because this is math. So this one's even better. Yes. What's that? Oh, like this? Let's see what FOIL is. This stands for firsts, outsides, insides, last. All it's doing is, if you have two binomials, it only works for binomials. Remember what that is? Two polynomials that are binomials and you're multiplying. That's when FOIL can work. It's multiple distribution. So let me put it over here. A plus B, C plus D, two binomials. So remember how this works? You distribute the A, and then you distribute the B. So the A's, those are the first two terms in the polynomials, right? A times C. Then it says do the outside ones. See how these are on the outside? That's your AB. Then it says do the inside ones. That's the BC. And then it says do the last one. The B and the D. So this just helps people remember how to do it. You don't want to do it, you don't have to. Just remember, distribute the A, distribute the B. You're fine. It's just everybody in this whole world uses FOIL. I don't want you to go to Algebra 2, and your Algebra 2 teacher says, why don't you just FOIL it? It becomes like a verb. You're not going to know what they're talking about. I'm telling you that. Yes?
Would it still work if you had it the opposite way, like
Yes. Yes, it does. That's an interesting question. Let's try it. First, now I'm writing them in alphabetical order. C times A, I like writing in alphabetical order. That's first. Outside, C times B, I'm going to write it as B times C. Insides, that's AD, right? Last, BD. Is this the same as what I got over here? Now the order's slightly different. Is that okay? Yes, right? You have the community property of addition. So yes, remember, it does not matter what order you multiply things. So that's fine. That's a really great question. Before we do the use tries, I want to actually just do a couple of them with you. Like, let's try this one together on A. So you're going to distribute this x. So x times 2x squared. What do you get? 2. No? 2. That's what multiplies. Quiet. All right. There's like an invisible one here. If you need to see it, put it in. 1 times 2. 2. X times x squared is x cubed. Right? You have 1x times 2 more x's. There are 3 x's. X times negative 3x. Negative 3x squared. I want everybody out of autopilot because you're confusing when to add and when to multiply. You are multiplying an x times a negative 3x at that. So it's a 1 times a negative 3, which is a negative 3, and x times an x is an x squared. So slow down. You're not in a big rush. Let's really think about it. X times 9. 9x. I like the pause. Okay? I'm going to let you do this one. You're going to be careful with this negative. Let's do C. Okay? So x times x.
x squared?
X times negative 3.
Negative 3x.
Inside, 2 times x. Plus 2x. And then 2 times negative 3. Combine those like terms here. I call them the outsides and the insides. That's the OI. You have to combine those because they are combining like terms. What's minus 3x plus 2x? All right, try these other ones. Be careful with E. FOIL doesn't work with E. You're going to distribute the x, and then you're going to distribute the 4. So give these guys a try. All right, how you may not have finished them all. How are we doing? Do we at least match, like say here for B? This one's a little bit trickier, right? X cubed plus 6x squared minus 5x. Where's that coming from? Distributing the x. Plus 4x squared plus 24x minus 20. How did I get that? That's distributing the 4. Combine like terms. I've got an x cubed. That's the only one I see. 6x squared plus 4x squared. That's where I got the 10x squared. Minus 5x plus 24x. That's 19x's. And I've just got my minus 20 left. So you always want to kind of do that collection. Collect all the like terms together. This one's a little bit harder, so if you got that one, congratulations. You're still working on these ones, that's what you do? Yes? Question? Yes? G is.
Oh, actually.
G asked about G, I love that. Okay, so, this is at length X, and this is length 5. So how do we find the length of the whole thing? You would say X plus 5. So that was a 2, right? That would be 7. That was a 3, 8, right? You add them. So what's this side? Yeah. So this is. So we're going to multiply them. That's how you find area. Length times width. X plus 3 times X plus 5. Right? That's how I got this bit. Remember FOIL here first. Outsides. Yes, you can. Inside.